Betelgeuse or Betelgeuse, a red monster star, nearly their Jew, a red monster star, it is an enormous wonder. Expecting that you put it where the sun is, it would connect to the circle of Jupiter. It's giant through and through, delicate, and it's going to detonate. Prepare for an enormous fiasco of never-before-seen scale. Betelgeuse, the red Goliath star on the edge of our pompous structure, is passing on disturbing messages through space. Cosmologists have followed down something fundamentally disturbing about this colossal thing, utilizing the James Webb Space Telescope. Prestigious researcher Brian Cox has given a limit condemnation. The question that keeps on coming up is, are we going to see a gigantic impact and influence that will change the night sky forever? The riddle of scarab juice in the boundlessness of the universe. Stars are envisioned to live and die in astounding ways. Really, one star has gotten the eye and stress of both space-trained professionals and everyone. Creepy Crawly Jew, a red, very Goliath star in the brilliant body Orion. It is staggeringly gigantic and old. Its outstanding bronzed arrangement and developing grandness have for a long while been hypnotizing, yet late occasions have raised interest in this enormous monster. As we sort out more about Creepy Crawly Jew, we are very near a possibly uncommon occasion in its set of experiences. Anyway, what could these movements in scarab juice mean? Are we seeing the start of an astonishing show on an incomprehensibly tremendous scale? Insect juice's enormous size and life cycle. Insect Jew is a fantastic beast, on various occasions more noteworthy than our sun. Its size is nearly past human ability to make sense of. Envision a star so immense that, assuming it supplanted our sun, its surface would stretch out past Mars' circle, wrapping Mercury, Venus, Earth, and Mars. This colossal size not only depicts the genuine meaning of creepy crawly squeeze, but additionally shows its stage in the heavenly life cycle. As a red super Goliath, insect juice is moving nearer to an bewildering complete, the process of extending and cooling, subsequent to debilitating the hydrogen in its focus and joining helium. The age and progression of scarab squeeze. This star is assessed to be somewhere in the range of 8 and 8.5 million years of age. While fairly young in human terms, it is old in immense terms. Over more than a long period of time, Betelgeuse has gone through significant changes, creating from a hot blue star to the red Goliath we notice today. It is presently in its last stage as a red supermonster. Stars like Betelgeuse change all through their lives on account of the constant types of atomic combination and gravity. Another brand name that makes the time of Betelgeuse important is its magnificent ruddy variety. Its red tone emerges from its cooler surface temperature contrasted with different stars like our sun. Its splendor changes and verifiable records show that the sun's surface is around 5,500 Kelvin, while Betelgeuse's surface is around 3,500 Kelvin. This cooler temperature permits creepy crawly juice to transmit light at frequencies that make it seem red. At any rate, this tone is some different option from an appearance. It uncovers information about the star's real state and the cycles happening inside its gigantic vaporous volume. Insect juice's variety has changed over time. The way that insect juice's tone has changed over the long haul adds to its secret. Historical records from Roman and Chinese times show that Betelgeuse was yellow as of late as 1,000 years ago. By the 9th century, Arabic stargazers saw its red variety. This shift over the course of mankind's set of experiences isn't simply a historical reference. It implies the star's advancement, the unimaginable lessening event. Another captivating piece of Betelgeuse is its changing quality. It is a semi-customary variable star, meaning its splendor fluctuates once in a while. This melodic obscuring and illuminating have excited researchers and stargazers for many years. Consistently, Betelgeuse undergoes a multi-day cycle and a more extended 5-year cycle. When, in 1836, Sir John Herschel documented these cycles, and nearby individual stories could trace back even further. Anyway, what genuinely makes Betelgeuse odd isn't simply its brightness changes, but their anomaly. Dissimilar to many stars that differ in splendor routinely, scarab squeeze sometimes wanders off track from this model, suggesting confused and less sorted-out processes inside its enormous development. Amazing perceptions and later developments. What's more, later upgrades as of late, space-trained professionals and cosmologists were stumbled to see a profound and alarming change in Betelgeuse's appearance. This brilliant darkening has raised different sorts of speculations. This is now known as the phenomenal obscuring. In late 2019, the red, very monster scarab juice, one of the most splendid stars in the evening sky and a perceptible component of the grand body Orion, began to decline bafflingly. The star was decreasing so quickly that it started losing its light at a speed of 0.01 extents every day on average. By February 2020, it was at its dimmest. Unusually, scarab juice, which can ordinarily be seen with the unaided eye, even in districts with significant light contamination, ended up being much fainter, and, surprisingly, easygoing spectators could see the distinction. The secret of time and light delays. However, the time secret entangles perceptions of Betelgeuse's exercises as light takes such a long time to contact us. When we notice a star like Betelgeuse, we are not seeing it as it is now, but as it was in the past. For Scarab Squeeze, the light we see today left the star right around a long time ago. This deferral makes for seeing speedy changes in its behavior testing. Andrea Dupree, the delegate top of the Community for Cosmology at Harvard and Smithsonian, and her gathering closely noticed Betelgeuse's brilliant show as some portion of a 3-year study to follow changes in Betelgeuse's external climate. They utilized the Hubble Space Telescope to notice the huge star. These perceptions gave new experiences into how a variable star like Betelgeuse works. The Hubble Space Telescope and the secret of Bug-Ju. Variable stars constantly create and contract, causing changes in their splendor. Analysts had the option to look at the layers above creepy-crawly Juice's surface, fairly warmed by the star's twirling convection cells. On account of Hubble's antipathy for bright light, further investigation of Hubble spectra taken at various times in 2019 and 2020 uncovered the improvement speeds in Betelgeuse's upper climate, the arrival of material, and its results. The spectra were principally made from magnesium, showing that material was moving from Betelgeuse's surface into its air at around 200,000 miles per hour. The discharge and mass loss of this hot, thick material eventually traveled thousands of miles from Betelgeuse, forming the dust cloud that darkened the star during the 3 months of discharge. Dupree and her group assessed that about twice as much material was catapulted from Betelgeuse's southern side of the equator. While all stars lose mass over time, Betelgeuse's mass loss was especially unmistakable on the grounds that it occurred at a much faster rate than the Sun's. Cosmologists thought about whether this occasion could signal an approaching enormous blast, given the size of the mass release and the subsequent obscuring. Being just about 725 light-years from Earth, Bug-Ju adds to the interest, as any such impact would be conspicuous from Earth and offer an interesting valuable chance to concentrate on a cosmic explosion up close. Betelgeuse's future. But the question remains, what does this obscuring mean for Betelgeuse's future? Is it an indication of an unavoidable infinite blast? Or is it essentially a one-time occasion in the star's long and complex life? A few theories have been proposed to make sense of this fast transformation. One well-known hypothesis proposes it was a forerunner stage in the cosmic explosion process, acquiring speed due to the belief that Betelgeuse is moving toward the end of its life. Another theory proposes that dust, possibly from the star itself, was impeding our view. The reality that Bug-Ju and other red super-Goliaths shed material, which could assemble into a residue cloud sufficiently thick to impede the star's light, is one chance. A third hypothesis analyzed how changes in the star's photosphere, the apparent external layer, could impact its clear brilliance. This secret was tended to utilizing a mix of observational procedures and inside and out investigation. Spectroscopic assessments and discoveries showed that Bug-Juice's effective temperature had diminished, suggesting that the star may be diminishing because of a gigantic dim spot on its surface. The way that Scarab Juice's temperature decreased by something like 170 Kelvin around the hour of the obscuring supported this thought, showing huge changes on the star's surface. The role of the Hubble Space Telescope. Finally, the Hubble Space Telescope, humanity's sentinel in space, helped us understand what was going on with this interesting occasion. Hubble's perceptions showed that it was likely due to the obscure of scarab juice from too much hot matter being jettisoned into space. This material formed a residue cloud that darkened part of the star's surface, reducing the amount of light arriving at Earth. The residue cloud was believed to consist of extremely hot plasma that emanated from huge convection cells on the star's surface. As this plasma went through Betelgeuse's hot air to cooler external layers, It formed dust grains that made a cloud, blocking light from about a fourth of the star's surface. The impact of the ejected material. The impact of the ejected material was evident from Hubble's ultraviolet light spectroscopic evaluations, which began in January 2019. These appraisals were critical in figuring out the events leading to bug juice's diminishing. They identified thick, hot material traveling through the star's atmosphere months before the darkening. Some ground-based telescopes also noticed the star's splendor decline in December 2019, with Hubble's perceptions confirming these discoveries and providing further insights into the ejected material. The fate of red supermonsters. The discovery that Betelgeuse was losing material at a much faster rate than previously thought led to the realization that this quick mass loss could impact how we might understand heavenly development, especially in red supermonsters. Red super Goliaths in heavenly development. It's important to understand that Betelgeuse isn't the only star going through such dramatic changes. Other well-known supernovae, such as SN 1054 and SN 1987A, have provided significant insights into how stars die and how new elements are formed. These past events have helped shape how we understand heavenly deaths and their impact on the surrounding space. For instance, SN 1987A, which occurred in a neighboring system, offered a close-up view of a cosmic explosion blast and its result. Such cosmic explosions add to the astronomical cycle by scattering heavy elements and affecting star development potential. The effect of insect juice's potential cosmic explosion. If Betelgeuse eventually turns into a cosmic explosion, it would create a terrific light show visible from Earth. The blast would be brighter than the moon and might actually be seen during the day. Such an event would offer an incredible opportunity to study the final phases of a massive star's life, as well as the development of large structures and the spread of heavy elements across the universe. Notwithstanding the dramatic nature of a cosmic explosion, the distance between Betelgeuse and Earth provides an eternal shield, ensuring that such an influence is unlikely to harm us directly. The insights gained from observing bug juice's potential change will continue to advance our understanding of heavenly development and galactic phenomena. The role of red super Goliaths in heavenly development is crucial to our understanding of astronomical evolution. These stars represent the final stages of a massive star's life cycle before it undergoes a cosmic explosion blast. Their colossal size and relatively short life expectancies make them brilliant laboratories for studying the end stages of heavenly development. Red supermonsters play a vital role in understanding how massive stars evolve, as well as the processes that lead to their disastrous deaths. These stars have a massive impact on their surrounding conditions. The energy they release in their final stages contributes to the development of heavy elements, which are key for the production of planets and life as we know it.